Hey, how you guys doing today? I miss seeing everybody. I hope you're having a happy quarantine. Um, we're going to attempt a little bit of notes today, okay? And if you haven't seen, there's something on my forehead. Take a moment to enjoy that. It took me approximately 4 hours, 4 whole hours to record that and draw that, and for you. Anyways, we're going to move on to our notes now. So if you guys should have picked up that insulation diagram sheet. Has a whole set of notes on a piece of paper that we've been taking notes on for a while now. So I'm going to show you what that looks like. You should see. Looks like this right here. Okay, we did a whole bunch of things on it. All right, we're going to flip to the back. Insulation diagram. I've perfectly recreated that right here. Really nice and neat. And we're going to draw it together so that we are all on the same page. Okay. Insulation is actually three words that they kind of merged into one, right? It's actually incoming solar radiation. Like this, okay? So incoming solar radiation. And really what that means, solar radiation, that means sunlight, right? So basically what we're talking about is what happens to light from the sun when it hits our atmosphere. What happens to light what happens to sunlight specifically when it hits our atmosphere, okay? So we're talking about light from the sun. So we got to get the sun on there. Now, you guys might know that the sun is yellow, okay? On this set of notes, it's going to be orange. All right, because I found yellow didn't show up so hot on this program here. So we're going to stick with yellow on that one. And we're also going to draw a couple other things. We're going to draw a cloud down here. This is a perfect recreation of a cloud. Some of you are probably doubting that at this moment, but you're wrong, and I'm right. All right, here's another perfect recreate. Oh my, that one's even better than the first one. I think we can all agree. Do we all agree? Yeah, we do. So here's what we're going to do now. We're going to draw what happens to the different types of light. All right, I'm going to go back to my yellow orange marker to represent light from the sun. And what we find is that sunlight from the sun will literally hit, the top of the atmosphere, even though there's no true top of the atmosphere. We're going to pretend. And then reflect back to outer space, just like that. Okay. Some light from the sun will go through the atmosphere and hit a water molecule, or maybe it'll hit a solid aerosol in our atmosphere, like ash from a volcano or smoke from a fire, maybe even an ice crystal somewhere up in the atmosphere. It'll hit something and bounce back into outer space. All right. Some light from the sun will actually make it all the way through the atmosphere. And that's the sound it makes too. If you could hear it, it'll go all the way through the atmosphere, hit the ground, and then hit something shiny. Maybe it hits something like freshly fallen snow or ice or something along those lines. And it'll bounce back into outer space. Oh, Mrs. Ballore is walking through. Everybody say hi to Mrs. Ballore. You can't be seeing this right here. Do you want to put your hand right here? That's Mrs. Ballore's hand. All right. Thanks, Mrs. Ballore, for your contribution to everything we do here, which is nothing, by the way. And this light that reflects back outer space. Hey, she just said I'm number one, everybody. All right, here we go. Let's go out. This light that bounces back to outer space, we call this albedo. And there you go. You see albedo. Now, albedo is much more important than we ever really knew up until probably the last 10, 15 years. We've only just begun to scratch the surface of its role in climate and climate change. But we now understand that it is a very important piece to climate change. And I'm going to define it over here in blue. Albedo is the percentage of light from the sun, percentage of insolation, that reflects back to outer space. Now, what's important is that when light reflects, it does not transfer any energy. All right. The light doesn't transfer any energy to the substance. It just goes right back into outer space. When it gets absorbed, when light gets absorbed, the energy from the light is transferred to the substance. All right. But again, this is reflected light. So there is no transferred energy. All right. Now, what does this mean? Well, what this means is that when the Earth has a high albedo, if you increase albedo, it reflects more light back to space. And since it's not transferring energy, it's reflecting the energy. What ends up happening is Earth gets colder. We get a cooler Earth. All right. Right now, we have ice caps on the North and South Pole. And ice caps, they got a lot of ice and snow. And ice and snow, fresh snow especially, can reflect up to 90% of the light from the sun, which means 90% of the energy is reflected back to space. No energy is transferred. And that cools the Earth. But as you guys know, the ice caps are melting. And as the ice caps melt, they expose dark ocean or they expose dark land. And as a result, dark land and dark ocean can absorb more light from the sun. They have a lower albedo, and so the energy gets transferred. So what we're in right now, folks, is we're in what's called a feedback loop, where as the Earth warms, it melts the ice. And as the ice melts, it warms the Earth faster, which then melts the ice faster, which warms the Earth faster, which melts the ice faster. As a result, Earth's getting warmer. All right. Good news is that we can do something about it. Humans have the ability to do something about this feedback loop if we wanted to. All right. Oh, Mrs. Bloor's back, but let's pretend we're going to be real nice.
You just want to be learning about biology.
Yeah, biology smells like formaldehyde.
Forensics.
You
guys don't see Mr. Dawson for a couple of days. Don't go searching.
I have no idea what she's talking about. I almost never do. She just talks about random stuff. Anyways, we're going to go back to this beautiful diagram. And the one other thing I want to add here is that if you decrease Earth's albedo, which is what's currently happening right now, we increase the temperature of the Earth. All right. So that's what's currently happening right now. We're decreasing albedo, increasing the Earth's temperature. All right. Back to the beautiful diagram here. Sunlight from the sun actually travels through the atmosphere, crashes into something like a cloud or something like that, gets absorbed by the atmosphere. Oh, right. Thanks. That says gets, believe it or not. I don't know why I put the apostrophe. It gets absorbed by the Atmos. Okay. Now, that could be something like an ultraviolet ray. Ultraviolet radiation hits an ozone molecule, gets absorbed. That's good. Protects us from ultraviolet radiation. Right? Could just be a cloudy day and some sunlight gets absorbed by a cloud. That happens too. Okay. Now, what happens to all the rest of the light? Well, the rest of the light will travel through our atmosphere unimpeded for the most part, reach the surface, and actually get absorbed by the Earth's surface. Right? So Earth absorbs. And this is roughly 50% of insolation that reaches our atmosphere is absorbed by Earth. Now, 50% right now. But as we talked about, our albedo is decreasing, which means our absorption is increasing. This number is actually on the rise. So this is increasing as the ice caps melt. All righty, folks, there you go. There you have it. This is the insolation diagrams. The most important factor, again, 50% of light from the sun gets absorbed by the Earth due to climate change. This 50% is increasing. That's a global average. That number is increasing, which is going to cause the temperature of the Earth to increase. Now, that is not the only factor. There are other factors playing a role in climate change, but this is definitely something we need to consider, and we're going to talk more about it when we get to climate change. All righty, folks. Let's see how this. Oh, God, I still have that thing in my head. Why didn't anybody tell me I still had this thing in my head? Did I mention that it took me like 2 hours to write this and draw this? Well, all right. Goodbye, everybody. I'm going to see you very soon. We're going to do the greenhouse effect diagram next. Keep your eyes open.